Gauss law. The Gauss law states relation between electric flux enclosed in a surface to the total electric charge enclosed in that surface. According to Gauss law, the total electric flux through any closed surface is directly proportional to amount of charge enclosed in that surface. What are the uses of Gauss law? Where we apply this Gauss law? Uses of Gauss law. The first one is to find electric field at a given point due to symmetry in charge distribution. That means throughout the body, charge is distributed uniformly. Due to the charge at a given point, what is the electric field value? In that calculations, we use Gauss law. Similarly, Gauss law gives total electric flux linked with a closed surface. It is used to find total flux associated with closed surface. And for different kinds of charge distributed bodies, to calculate electric field intensity, we use Gauss law. What kind of charge distributions are there? Linear charge density means charge distributed throughout the length of the body, that we called linear charge density, lambda. If the charge is distributed throughout the surface, that we called surface charge density, sigma. And the third one is volume charge density. Charge is distributed throughout the volume of the body, that we denoted with rho. For such kind of charge distributed bodies, to find electric field intensity, we apply Gauss law. These are the uses of Gauss law. Now, what is the Gauss theorem statement? Gauss theorem statement. What is that? The total electric flux linked with a closed surface is directly proportional to charge enclosed in that surface. Phi directly proportional to Q enclosed. What is this phi? The total flux linked with a closed surface is directly proportional to amount of charge enclosed in that surface. Phi is equal to, by removing this proportionality, a constant, that is 1 by epsilon naught into Q enclosed. The total flux linked with a closed surface is equal to 1 by epsilon naught times to the total charge enclosed in that surface. This is the statement of Gauss theorem. Once again, the statement of Gauss theorem. The total electric flux through any closed surface is equal to 1 by epsilon naught times to the net charge enclosed by that surface. Here, what is this epsilon naught? Epsilon naught is the permittivity of free space. Now, a closed surface S encloses a charge Q. Then, according to Gauss theorem, the flux linked with this closed surface is 1 by epsilon naught times to this charge Q. Phi is equal to 1 by epsilon naught times to charge enclosed in this surface, that is Q. But according to definition of the Gauss theorem, definition of the electric flux. The flux is the dot product of electric field intensity and area vector. By the definition, total electric flux through a closed surface S is given by phi is equal to closed integral E bar dot ds bar. So, from these two equations, phi equal to closed integral E bar dot ds bar is equal to 1 by epsilon naught into Q enclosed. Hence, Gauss theorem states that the total electric flux through any closed surface is equal to 1 by epsilon naught times to the net charge enclosed by that surface. Now, the proof of Gauss law. To prove this Gauss law, let us consider a point charge Q inside a closed surface as shown in figure. Imagine a sphere B of small radius small r with charge Q at the center of the sphere. This is the diagram. This B is the sphere whose radius is small r. A charge Q is placed at the center of the sphere and the closed surface is this one. This is the closed surface A. Now, electric field at any point on the surface of sphere B is given by, due to a charge Q at a distance small r, at this point the electric field intensity. Due to point charge, the electric field intensity E is 1 by 4 pi epsilon naught Q by R square. This is electric field intensity on the surface of this small sphere B due to a charge Q is placed at its center. What is its expression? E is equal to 1 by 4 pi epsilon Q by R square. Now, consider a small elemental portion ds. This ds is the area of this element. Now, for this element which situates on the surface of the sphere B, the flux through this element is d phi is equal to electric field intensity at this point is E bar and ds bar is the area of this element. Then flux through this small elemental area is d phi equal to E bar dot ds bar. This is second equation. From 1 and 2 equations, by substituting 1 in 2, we get d phi equal to E bar dot ds bar, that is 1 by 4 pi epsilon Q by R square into ds. This is what? Electric flux through the small element. But we need electric flux through the entire sphere due to a charge Q placed at its center. To calculate that, we have to integrate this equation. That is, integral d phi is equal to integral 1 by 4 pi epsilon naught Q by R square ds. Integral d phi is nothing but phi. So, phi is equal to 1 by 4 pi epsilon naught Q by R square constant integration ds. What is ds? ds is the area of the small element on the sphere. Now integral ds means total area of the sphere B. So that value is 4 pi small r square. That 4 pi small r square, substitute here in place of this as 4 pi cancel, r square also cancelled out. The remaining equation is phi equal to q by epsilon naught. What this equation states? Total flux enclosed in a surface is equal to 1 by epsilon naught times to the net charge enclosed by the surface. This is the Gauss theorem. Hence, Gauss theorem is proved. Now, MCQs. The first one is, in Gauss theorem, the total electric flux over a closed surface is equal to, the options are 0, 1 by epsilon naught times the charge enclosed within the surface, product of enclosed charges, none of the above. According to Gauss theorem, the total electric flux over a closed surface is equal to 1 by epsilon naught times to the charge which is enclosed in that surface. So correct option is B. Now, problems based on electric flux and Gauss law. The first question is, a cube is arranged such that its length, breadth and height are along x, y and z directions. One of its corner is situated at the origin. Length of each side of the cube is 25 centimeter. The components of electric field are Ex equal to 400 root x Newton per Coulomb and Ey is 0. That means there is no electric field along y and z direction respectively. The total flux coming out of the cube will be. This is the question. The options are 12.5 Newton meter square per Coulomb, 0, 12.5, 1. Solution. The electric flux phi is E bar dot S bar. Phi is equal to E bar dot S bar. What is E bar? Electric field intensity value. Here E bar is 400 root x I cap because only along x direction electric field component is there. So E bar value is 400 root x I cap. S bar is the area vector. At what distance we are going to calculate? At x equal to 25. Why? Because the length of the each side of the cube is 25 centimeter and one of its corner is situated at the origin. Means origin to another end is at a distance of 25 centimeter. Now E bar electric field intensity 400 root x. What is x? Side length of the cube, that is 25 centimeter. 25 centimeter means, to convert into meter, 10 power minus 2. Along which direction it is exist? X axis. I cap. This is electric field intensity in vector form. Similarly, E bar equal to 400. 25 square root is 5. 10 power minus 2 comes out from the root as minus 1. I bar. Next, the area vector A bar equal to length into breadth. 25 into 25. Centimeter, centimeter. Converts into meter. 10 power minus 2, 10 power minus 2, that is 10 power minus 4 I cap. E bar, electric field intensity. A bar, area vector. Both are there. Then the dot product of these two vectors is the electric flux. Phi equal to E bar dot A bar. A bar, S bar, these two are indicating for area vector. So by substituting these two in the formula phi equal to E bar dot A bar, we get the answer like this. In further simplification, we get flux value as 12.5 Newton meter square per coulomb. This is first option. Option 1 is correct. Next question. 8 dipoles of charges of magnitude E are placed inside a cube. The total electric flux coming out of the cube will be. Dipole is an arrangement of two equal unlike charges separated by a small distance. Here, if we enclose this dipole in this closed surface, the net charge is minus q plus q. Sum of these two charges is the net charge, which is equal to 0. That means for a dipole, the flux due to dipole is 0. Why? Because net charge in a dipole is 0. Minus q plus this plus q. Total charge is 0. So, the flux enclosed by this closed surface is 0. Here, inside the cube, total 8 dipoles are there. For each dipole, flux is 0. Then for 8 dipoles also, flux is 0. Solution. Phi is equal to Q net by epsilon naught. Here, Q net value is 0 for each dipole. Like that, how many dipoles are there here? 8 dipoles. For 8 dipoles, again the charge enclosed in the cube becomes 0. So, correct option is fourth option. Next problem. A charge Q is placed at the mouth of a conical flask. The flux of the electric field through the flask is. Options are 0, Q by epsilon naught, Q by 2 epsilon naught, less than Q by 2 epsilon naught. Solution. According to problem, a charge capital Q is placed at the mouth of the conical flask. Now, through this flask, what is the electric flux? To calculate that, here charge has to enclosed. To apply Gauss law, we need an enclosed surface. To enclose this charge, I am assuming another conical flask like this. Now, the charge is enclosed. The total flux here is phi is equal to Q by epsilon naught. This flux linked with two flags. Now flux through the each flask, that is flux for one flask is equal to, for two flask, flux is Q by epsilon naught. For one, half of this one, that is Q by 2 epsilon naught. This is the solution for this problem. Once check the solution. Half the flask passes through the cone, which is equal to Q by 2 epsilon naught. Hence, third option is correct. At the center of the cubical box, plus capital Q charge is placed. The value of total electric flux that is coming out of the each phase is. Options are Q by epsilon naught, Q by 3 epsilon naught, Q by 4 epsilon naught, Q by 6 epsilon naught. Solution. Here, inside this cubical block, A plus Q charge is placed at the center. Now, flux through the total cube is Q by epsilon naught according to Gauss law. What is this Q plus capital Q? That means total flux is Q by epsilon naught. This Q by epsilon naught flux is the total flux through this cube. This cube contains total how many phases? 1, 2, 3, 4, 5, front face 6. That means this Q by epsilon naught total flux linked with 6 phases. Now, flux through the each phase. For 6 phases, flux is Q by epsilon naught. For each phase, flux is Q by 6 epsilon naught. This is the explanation. Once go through the solution. Flux through the total cube is Q by epsilon naught. This is for 6 phases. Now, for each phase, flux is Q by 6 epsilon naught. Hence, fourth option is correct.